We want to use Newton's method to estimate the solution to the equation y equals x squared plus x minus 1 equals 0. And we're going to take a left-hand solution and a right-hand solution approach. So we're going to start with x0 equals negative 1 and x0 equals 1. And our goal is to find x of 2. So in general, we know that x of n plus 1 is x sub n minus the function evaluated at x sub n over its derivative. In our case, we can say that f of x is x squared plus x minus 1. So we can plug in x sub n inside for x. And then for the derivative, we know that's just 2x plus 1. So we're going to substitute in x sub n inside the derivative. Okay, and so this will be our x of n plus 1. Okay, so let's first start with x0 being negative 1. And we want to find x of 2. Okay. Now x sub n, or x sub 1, that's when n is equal to 0. Okay. So we're just going to plug in n equals 0 here. And replace the x sub 0s with negative 1. And for that, we end up with negative 2. So x sub 1 is negative 2. Now we move on to x sub 2. X sub 2 will be x sub 1, and then minus x sub 1 squared plus x sub 1 minus 1 over 2 times x sub 1 plus 1. X sub 1 we just found was negative 2. So we're going to substitute that in. And we get negative 5/3. Okay, so x sub 2, starting with x0 equals negative 1, gives us negative 5/3. Now we're going to start at x0 equals 1. So x sub 1 will be 1 minus, and then we're just going to plug it in, 1 plus 1 minus 1 over negative 2 plus 1. I'm sorry, 2 plus 1. Right, because it was f of x was x squared plus x minus 1. The derivative, we said, is 2x plus 1. Okay, so x here plays a role of 1 because that's x of 0. And now for x sub 2, that's just x of 1. And of course, I forgot this is 2/3. X of 1 is 2/3 minus, now we do 2/3 squared is 4/9 plus x, which is 2/3 minus 1 over 2x. Well, it's 2 times 2/3 plus 1, and that gives us 13 over 21. So those are our x2s. Let's look at the second example. So this one, we're going to find the solution for y equals x cubed plus 3x plus 1 equals 0. We're going to start with x sub 0 is 0, and our goal is to find x sub 2. Okay, so first let's find the derivative. It's 3x squared plus 3. And now we want to use Newton's method. So x sub n plus 1 will be x sub n minus f of x sub n over f prime of x sub n. Okay, so in our case, we just have to plug it inside both functions, the x sub n. Okay, so if x sub 0 is 0, x sub 1 will be x sub 0 minus f of x sub 0. So that would be x0 cubed plus 3 times x0 plus 1 over 3 times x0 squared plus 3. We're going to plug in 0 for x0, and we get negative 1/3 is x1. Okay, now we're going to go to x sub 2. So we're going to have x1, which is negative 1/3, minus, see, x1 cubed plus 3 times x1 plus 1 over 3 times x1 squared plus 3. So when we simplify this, we end up getting negative 29 over 90. All right, let's look at one more example here. This one, we're looking at y equals x to the fourth plus x minus 3. Okay, we're taking two approaches. One will be x0 equals negative 1, and the other one is x0 equals 1. And our goal is to find x sub 2. Okay, so let's find the derivative. That will be 4x cubed plus 1. Okay, and then we know that x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. Let's start with x0 equals negative 1. Okay, so x sub 1, we'll plug in at n equals 0, so that'd be x0 minus, here, I guess we could just do it an extra step. So this will be x0 minus x0 to the fourth plus x0 minus 3 over 4 times x0 cubed plus 1. Since x0 is negative 1, we're going to plug that in. And for that, we get negative 2. Okay, so x sub 1 is negative 2. Now x sub 2, that's x sub 1 minus x sub 1 to the fourth power plus x sub 1 minus 3 over 4 times x sub 1 cubed plus 1. And that is negative 51 over 31. Okay. So x sub 0 equals negative 1 is complete. Now we're going to look at when x sub 0 is 1. And so that's x0 minus x0 to the fourth plus, let's see, x0, which is 1, minus 3 over 4 times x0 cubed plus 3. Oh, sorry, plus 1. And that would be 6/5. And one more step for x2. x2 is x1 minus x1 to the fourth plus x1 minus 3 over 4 times x1 cubed plus 1. And that would just be 5,763 over 4,945. And that is our final answer.